Hi, good morning, good afternoon, and good evening, wherever you're joining the session from. Welcome to this session titled Climbing the Data Peak, Data Modeling for Couchbase Server, which is a part of your Developer Associate certification. My name is Clarence Tauro. I work as Global Lead Instructor at Couchbase. In this session, we'll be talking about data modeling. We'll be talking about the JSON document design, the physical data modeling for JSON, talk about various things related to data nesting, talk about the various trade-offs that we have when we talk about data modeling, and we'll talk about embedded versus referring. So the first question is, what is data modeling? Right? I didn't have to do much about it. I just Googled what is data modeling, and I got a huge set of definitions. Right? So I just copied and pasted here on this slide. Okay, let's read them out. Okay, precisely explaining a subset of information for an application using symbols of text is what is data modeling. Creating an information model for an application by applying formal techniques is what is data modeling. Exploring the data oriented structures of an application is what is data modeling. When you represent data structures required for expressing and communicating business requirements of an application is what is data modeling. When you understand the data semantics of an application is data modeling. Identifying, documenting, and implementing the data requirements of an application is what is data modeling. So when you talk about briefly, data modeling is nothing but designing the data the way how it best suits your application. So look at this, designing the data the way how it best suits your application. So when I talk about data modeling, it is very application dependent, right? So when you look at the phases of data modeling is essentially a progression from conceptual data model to physical data, to logical data model to physical data model. So when you look at conceptual data model is like 10,000 feet overview of your data, right? You identify what are your entities. You identify what are the relationship between those entities. You identify what are the cardinality between those entities, right? While logical model is, or it depends on your target database, whether your target database is relational database or a key value database or graph based database. While physical model is your database dependent, right? You'll have to completely design your data model as per your underlying database, right? Underlying database, right? We'll talk about this while we proceed. So when you talk about conceptual data model, like I told, it's 10,000 feet overview of your data, right? You identify the entities and relationship between them, correct? And ER modeling is the most widely accepted tool for conceptual data modeling. ER modeling can be done using different notations, like you have Peter Chen's notation, you have Beckman's model, you have Crow's foot model, you have ISO or UML. But we recommend Peter Chen's model because it's not tainted by the relational model. For example, if you're using UML, right? So it kind of assumes that you're using some kind of object-oriented system. But if you're using ER diagrams, it's not tainted by your relational model, or it's not tainted by any kind of underlying technology. Right? Conceptual data modeling is completely independent of your target database system. Remember, you don't have to know how you're going to work with your physical model. It's just, it gives you a 10,000 feet overview of your data. Let's take an example. So if you look at the conceptual model here, I've identified the entities. Owner is an entity and pet is an entity. I've identified the attributes of owner: name, address, and phone number. Like I've identified the attributes of the pet as well: name, type, and license number. The relationship between them: owner has a pet, right? The cardinality between them: 1:n. That is, one owner has n number of pets. Let's take an example of the couch music data model. It's the same data model that you use in your certification, right? So you can see here, I've identified different entities. I've identified that there is an entity called as user. I've identified the playlist entity. I've identified the track entity. I've identified the relationship between them. User owns a track. Playlist contains, sorry, user owns a playlist. Playlist contains a track. User rates a track. They're different relationship. And look at the cardinality, 1 to n between user and playlist, which means one user can own n number of playlists. One playlist can contain n number of tracks, and one track can be contained in n number of playlists, right? So it's a m into n relationship. Likewise, for user and track, it's a m into n relationship, which means one user rates multiple tracks and one track is rated by multiple users, right? So that's what you identify in the conceptual model. But when you're talking about logical model depends on the high level features of your target database system, whether you're using relational database, whether you're using graph based database, whether you're using key value kind of database. It depends on that, right? Logical data modeling for relational systems is much common practice and is supported by wide variety of mature software tools. But in case of most of the NoSQL systems, which lack formal methodologies for logical data modeling, right? So logical data modeling for NoSQL system focuses clearly on understanding. Look at this, clearly on understanding your application query requirements. How are you going to query your data from Couchbase? How are you going to ingest data to Couchbase? What is the flow of your application? Can change your data, right? So definitely this is an active area for of research in academia. Okay, so let's look at the logical model. If you look at this, what you see in front of you is the conceptual model, right, of a simplified order management system. Right? You identify different entities: customer, order, items, product, pay type. These are the different entities. Now, what logical model basically means here is, how are you going to group them? You identified your conceptual model. How am I going to group them logically? Which means now choice of grouping order and items together to make an object, or our choice of having order and pay type together and items and product together. The choice is yours. How do you want to logically group them is what is defined under logical data model. And this will actually impact your physical data model. So physical data model is technology dependent since each target database system is implemented differently. Most but not all NoSQL systems are schemaless, which means schemas are defined within the application by your application. So the best practices of physical data modeling for Couchbase Server focuses on understanding the data patterns of the applications being built, including the ingestion and queries. How are you going to ingest data to Couchbase? How are you going to retrieve data out of Couchbase? What is the flow of your application? Remember, can change your data model or can impact your data model. Right? So various trade-offs must be built in the applications if you want to perform at scale. So we're going to talk about a little later what are the various trade-offs that you're going to encounter. Okay, let's talk about the JSON document design. JSON is everywhere, right? 170 plus JSON parsing libraries, 60 different languages and frameworks that support JSON, right? You can find a variety of tools and resources at json.org or jsonlin.org, which is jasonlin.com, which is a validator, or jasoneditoronline.org, which is a JSON editor, right? And JSON is governed by RFC 8259. So if you talk about JSON these days, right, thankfully it has replaced XML as the most common format used in APIs. right? JSON is particularly useful in JavaScript apps because they can be easily serialized and deserialized. And of course, it has a number of supporting technologies like JSON path, like your XPath in XML, JSON schema, you remember your XHDs and DTDs, right? The same way, if you want JSON to be your JSON document to conform a particular schema, you can use JSON schema, but remember, it's at the application end, not at Couchbase's end, right? And GeoJSON for geospatial kind of applications. JSON has several worthy competitors like BSON, the format what MongoDB uses to store data, YAML, Avro, um, protocol buffers or message pack, different formats to do different things. JSON serialization libraries like Jackson or JSON exist for most popular programming languages. So you can use either of them. So when we talk about JSON physical modeling, remember, it's all about choices that we have. It's all about choices. So when you talk about Couchbase itself, it's divided into two parts, right? Every document in Couchbase is divided into two parts. You have the metadata and you have the data. So which means you have a chance of modeling for the metadata, and you have a chance of modeling the data attribute itself, right? So when you're talking about um, metadata, you have different things like data typing and versioning. So which means you can use key design, or you have document management fields. I'm going to talk about that in the coming slides. And various choices with the document structure itself, like the choice of the field name, the length, the consistency, the style, right? So the choice of using the root attribute versus the type parameter, the choice of objects versus arrays, right? What about array complexity? What about the different timestamp formats that's available, right? So you might have empty, null attributes, missing attributes, valued attributes. How do you deal with them, right? And how do you make sure your JSON conforms to a particular schema by using JSON schema? So we'll go through each of them. When you talk about the structural capabilities, if you look at this as your JSON document that's stored in Couchbase, you know it has two parts, right? It has the metadata and it has the data. Data could be anything. It's not necessarily a JSON document, but preferably a JSON document, right? So this is an example of a JSON document that's stored, and this is the metadata, where metadata has the ID, the revision, the expiration, cache, flags, type, and optionally the extra attributes, right? You know the key value. The key can take up to 250 characters, which means you can model your key as well, right? And value can be up to 200, up to 20 megabytes. Does not mean that each document has to be as large as 20 megabytes. That's the maximum upper limit, right? So when you talk about the documents itself, right? So document key prefixing is one of the way that you must have seen to identify the type of the document, right? So for example, you must have seen people doing this, that is order : 123, right? Or product : some UUID, or something like this, you know, application name underscore document type underscore ID, like this is an example: couch gadget underscore customer underscore acme underscore, you know, some UUID, right? Or document type : parent type child ID ID, like pay type : visa uh, this customer name the ID. Quite possible. So the question is, why am I prefixing here? What if I do not prefix, right? Let's take a simple example for that. How do I store, say, Clarence's login information, right? Login : 101. Clarence's orders information, orders : 101. Clarence's uh, logs information, log : 101. Clarence's sales information, sales : 101. You can see this 101 is being common there, right? What is changing is the prefix of the documents. So when I retrieve Clarence's login information, all I know is ID of Clarence's 101. I'm going to prefix login and I'm going to get that document. So the idea is I want to design my key such that the first way of accessing the document is by the key. Because remember, the fastest way of accessing the document in Couchbase is by the key. Of course, you can access the document by using nickel, you can use secondary indexes, you can use full text search, you can use analytics, you can access document in different ways. But what's the fastest way of accessing the document in Couchbase is by the key. You know the key, you get the document by the key. Nothing's faster than that. Right? So always design the key such that the first way of retrieving the document is by the key. Right? So when you talk about the keys, there could be different ways how you want the keys. Right? Keys could be natural or surrogate. What are natural keys? Natural keys are the ones that exist in the real world, like your phone numbers, your username, social security numbers, account numbers, SKU, UPC or QR codes, device IDs. Right? So these are the natural keys. Right? These are often the first choice for document keys as well. Right? But remember very carefully, right? You do not want to violate your PII or SPI or PHI. You'll have to be very careful while you're working with such information, right? What if you do not have a natural key? That's where you're going to use a surrogate key. So surrogate key is used often when no obvious natural keys exist, right? They're not derived from application data, but rather they are generated values like SHA or UUIDs. And you as developers know how easy it is to generate a UUID, isn't it? Right? You're going to say UUID.get UUID and you get a UUID of 25 characters or whatever length. Right? Of course, Couchbase also has atomic counter feature, which means you can use Couchbase atomic counter to generate counters, which is guaranteed to be atomic as well. Right? Document management fields. Sometimes what happens, let's take these examples like fields like type, version, created, created by, modified, modified by, accessed, last accessed by, last accessed geographical location. See, these are certain information that you want to make it a part of your data model, but it is not needed by the application itself, right? So this is something that's not needed by your application, but you still want it in your data model so that you can make your application behave the way you want to, right? So if you look at my earlier definition of data modeling is nothing but designing the data the way how it best suits your application, correct? And at some point of time, I want to know who is the person who modified this document, which is not a part of my data model, perhaps, right? So where do I store this information? I store this information within the document itself. I store this information within the document so that I satisfy my need of getting the last access person. It's not needed by the application, but it's needed by it's needed for me to get certain parts of the application worked. Say for example, I want to restore only the documents that were changed since 27th March 2020. Now, how do I track that information? That information is not there anywhere, right? So if I have kept this attribute or document management field within the document, that is say last access or last modified or the modified date, and now I can do this easily, right? I can restore only the documents that were modified or where underscore modified is greater than this date. I can do that. So I'm making my application behave, or there are certain things that I want to do and I'm able to do by having these fields for the management of my application. This may not be needed by the application itself, right? But for the management of my application, I might need that. Right? So it's a way how you would make things work, right? So again, more choices, like the choice of field name, the style, the consistency. So when it's a field name, right? So what about you just can use geocode versus or use country code. So which am I going to use? Probably geocode, right? Because there's only 7 characters, while this is 11 characters. 11 characters is not a big deal, but the problem is, what if you're saving like 5 characters and you have a billion documents? Now probably you're saving 5 billion bytes. Right? That's a lot. Right? So use self-documenting names. So instead of using use sys login text, which is not very obvious, please use username. Right? You can use first name where this is camel notation, or first underscore name, or first name, whatever suits you is all fine, but be consistent, right? You don't want to use mix and match that. Okay? So use plural names for any array fields like phones, right? Keep the rest as singular, like address, genre, right? Scale is all singular. Avoid using reserved words, right? Avoid using numbers, right? Or hyphens. Okay, it's not that it won't work, it's just that you'll have to enclose them using backticks. Then it becomes a hassle every time. Okay, okay, what are the other structural choices that I have? So have a look at this. So in this case, this document, right? This document has the type attribute. Well, this document is almost the same document, but it does not have the type attribute. Rather, it has the root element called as track. So if you're following along with your data models that are being used in your certification track, it's the difference between Couch Music 1. So this one is Couch Music 1, a track document in Couch Music 1, while this one is a track document in Couch Music 2, right? So I'm again not here to tell you which one is good. Rather, I'm here to tell you these are the choices that you have, and every choice has an impact, right? So here you can see here, if I keep this as my choice, in this case, I can index my track. While in this case, I cannot index my track. Maybe I don't want to, right? Maybe I'm getting my track by the keys. So in that case, I'm not worried about indexing. Maybe I'm worried about indexing. That's why I want this. Right? Remember, based on what I choose here, my query model also changes. In my first case, I'm going to query as select star from Couch Music 2, where type is equal to track. Select star from Couch Music 2, where type is equal to user profile. Select star from Couch Music 2, where type is equal to playlist. But if this is my case, I'm going to say select star from Couch Music. I'm not going to say select star from Couch Music 1. I'm going to say select track dot star from Couch Music 1. Select user profile dot star from Couch Music 1. Select country dot star from Couch Music 1. Right? So you can see here my query model changes. So choice of objects versus object arrays. So in this case, phones is a simple object. Well, in this case, phones is an array of objects. So what I recommend is try to keep as simple as possible. Try to keep your data model as simple as possible, right? In this case, phones is just a simple object. How am I going to access? User profile dot phones dot home. That's it. But in this case, I'm going to access it as phones of 0 dot number, right? Which means since it's an array, right, I have to iterate over an array, which is an additional complexity. I'm nowhere discouraging the use of arrays. Couchbase has array index, which is extremely powerful, which is extremely good, works perfectly. But what I am suggesting here is try to keep your data model as simple as possible. If you can do something without using arrays, I think you should do without using arrays. Right? So also have a look at this. In this case, Tracks is an array of strings. Tracks is an array of track IDs, right? So in this case, for every track that I need to play, I need to get the track. I need to join it. So if there is a playlist with 10 tracks, I need to do 10 gets. But have a look at the one at your right. So in this case, I have tracks, but I have a partial, tracks is an array of objects of partial track information. So there is a separate document called as tracks, that's fine. But within the playlist, I have, or within the playlist or within the user profile information, depending on wherever you are, whichever data model or however you are designing your data model. So in my case here, the playlist has tracks. So in my case here, playlist has partial embedded tracks here. I have not embedded tracks completely, but I have partially embedded them. So I partially embedded only the information that is needed to play the track, right? I need the MP3 location, I need the artist name, I need the genre, I need the ID of the track, I need the title of the track. That is it. So I've embedded that partially here. So I don't have to do any join. So a join is completely avoided here, right? So how is it impacting now? So do you see some difference? This document is like quite smaller, right? Isn't it? Because it has only track IDs. The document size is quite small. While on this case, right, the document size is bigger now. Yes, the speed of access is fast because there's no joins here. But on the other hand, the size of the document grows. So now the question is, what if I embed and embed and embed and embed and embed? The document size becomes bigger and bigger and bigger and bigger. And instead of your original intention of embedding, which was to increase the speed of access, the speed of access is completely dropped. You know why? Because large document takes more time to transfer across the network. It takes more time to serialize. It takes more time to deserialize. So your intention of embedding was to access at a greater speed. You're completely lost it because your document size has extremely grown. So basically that's the trade-off that we need to do, right? The trade-off of atomicity, trade-off of document size, trade-off of the speed of access, trade-off of the complexity of the document. Okay? We're going to talk about that again. So when you talk about date and time format, you have different choices now again. Correct? Look at this. So at least 3 different choices here. Yeah, you can store your data as ISO 8601 format. You can store data as epoch format, or store data as array of time components. Now, I usually prefer storing as epoch. One, because I don't have to care about locale then, right? Excuse me. I don't have to care about locale then. And Couchbase Nickel provides a variety of methods to convert from one format to another. So I just don't care, right? And I can sort in descending or ascending because it's just numbers. So it's pretty convenient for me. But what is the disadvantage of this is it needs some kind of conversion processing. This is not readable, right? I don't know what this data is now, right? So it's not so readable. So it's not so friendly, right? While this is like quite friendly here, right? So what about this format? This looks funny, but actually it's not, especially when you have to say get your data and display it in a time series kind of format, right? So I think this format pretty much works very well here. So those are the choices that you have, right? JSON schema. So when you look at Couchbase itself, remember Couchbase pays absolutely no attention to the shape of your JSON document as long as they are well formed. But there are times when it is useful to validate that your JSON document conforms to a particular shape, right? Remember, it's at the application level, not at Couchbase end, right? So JSON schema is a JSON based format for defining the structure of JSON data. And there are different implementations. You can visit jasonschema.org to learn more, but let's look at a sample JSON schema. So this is a JSON schema which is in JSON format itself for country, right? You can see here I've specified the different attributes, right? Like country code, GDP, name, population, and I've given them the different data types. Like for example, I can have different type specification, like it could be string, array, integer, boolean, enumeration, or so on, right? So for example, in this case, you can see type is a string and the min length is 2, the constraint, right? Min length is 2 characters. Max length is also 2, which means it has to be exactly same 2 characters, correct? Different specific validations. It can be minimum, maximum, min length, max length, format, especially for email format or datetime format, right? Or any kind of pattern, regex pattern. So, and these are the required, out of these properties that I've defined here, these are the required properties. Do I additionally allow any more properties? No, I have disabled it here. So remember, I'm just giving a schema for the country document. So my country document now has to conform this particular schema. But remember, not at Couchbase end. Okay, it's at the application end. Let's look at data nesting now. So as you know, relational database design promotes separating of data using nesting, which using normalization, sorry, I beg your pardon, using normalization, which does not scale, correct? For NoSQL system, we often avoid normalization, or rather, I won't use the term often avoid normalization. Rather, you should say we relax normalization so we can scale, right? You don't want to do more and more joins like what you do in relational database. Rather, you want to avoid joins. You want to relax the joins so that you can scale. Correct? So how do you do that? So nesting allows related objects to organize into a hierarchical tree structure where you can have multiple levels of grouping. I personally don't recommend more than 2 levels of grouping, of 2 levels of nesting. Couchbase does not recommend more than 3 levels of nesting unless you really have good reason to do so. Okay, I have really seen nesting gone up to like 7, 8, 9, 10 levels of nesting, which is not good at all, remember. Okay, and often you include timestamp when you are using nested data. Okay? Let's take this example to demonstrate nesting. So this is a playlist document and this is a user profile document, right? So when I'm in the playlist, let's consider I want to know what's the name of the playlist owner. So I need to do a join here. Look at this. The owner here represents the username here. I need to do a join on this, pull this document, and I get to know the name as Andy. The first name is Andy and the last name is Bowman, right? But so you can see there's a join here, right? So what if I did a partial embedding? So look at this. It's exactly the same set of documents, but in this case, I have partially embedded the owner information here. In this case, I have partially embedded the owner information here, right? So I don't have to fetch the user profile document. When I fetch the playlist document, I get the playlist information as well as the partial owner information. Like I get to know what is his first name, what is his last name, what is his title. But if I want to know his address, I'll do a get again. That's all right. Right? So my most needed information, the information that I'm most likely want to access, is what is kept within the nested element here. Right? So you might be asking, hey, am I not repeating the data here? The answer is yes, you are repeating the data here. You might ask, hey, if Andy changes his name here to Andy1, will I not have to change in every location where it is nested? The answer is yes, you have to. But the question is, how often does Andy change his name? So you get what I'm trying to say, right? So you only embed the information which is not likely to change often, right? Or if it changes, what is the cost associated to change that portion of information in all the nested attributes? Is it worth doing that? Are you okay with doing that? That's something that you need to decide, right? Let's take another example of data nesting. So look at this. Playlist has an array of track IDs. So in this case, I have to do multiple gets to play the playlist, because track is a different document now, right? But instead of that, what if I had kept a partial embedded information? So in this case, look at this. I've kept just sufficient information for me to required by me to play the playlist. So you can see here, I have stored the artist, the genre, the MP3, the title, right? And maybe the updated timestamp. Makes sense, right? So in this case, what happens is I don't need to do a get again. So everything, when I get the playlist, I get the tracks and the required information to play the tracks, the name of the tracks, the ID of the track, the title, and the MP3 location, right? But of course, remember the size of this document is quite big, huh? Right? That's the choice. That's the structural choice that you do. Okay, let's talk about the trade-offs now. So when you talk about the trade-offs, it's interesting, right? So I was browsing, like, what does trade-off mean? Right? And I found this definition so interesting that I made a slide of it. So it says trade-off is a situation in which you must choose between or balance two things that are opposite or cannot be had at the same time. You're choosing between things that you cannot have at the same time. Something that you do not want but must accept in order to have something that you want. That's trade-off. Beautifully defined, right? So when you look at the CAP theorem, CAP stands for consistency, availability, and partition tolerance. And you know, Couchbase is a CP system, consistency and partition tolerance system, right? Which means the bigger choice has already been done. So what's the choice that you have? Correct? The choices that you have when you're doing data modeling is the choice of document size, is the choice of atomicity, is the choice of complexity, the choice of speed of access. Right? Every choice that you make. So if you want more embedding, your atomicity is fine, it's perfect. Correct? The document is completely atomic now, but the document size is bigger now, which is a problem now. Right? So when the document size is bigger, the complexity of the document is higher, and the speed of access is probably lower now. Correct? So what you need is the balance. Correct? I don't want the document to be very small that it loses atomicity. I want to make it slightly bigger, but I don't want to make it so bigger that I lose on speed of access. So what is my balance? And that's the balance that you have to choose. You have to decide based on your SLA. Right? If you look at the document size, right? Couchbase supports documents up to 20 megabyte size. Does not mean that your document should be as large as 20 megabytes. Remember, large document takes more disk space, more time to transfer across the network, and more time to serialize and deserialize. So if you're dealing with documents that are potentially large, make sure you test thoroughly to find out if the speed of access is adequate as a scale. If not, you'll have to break down that document into smaller documents. The other way is to limit the number of dependent child objects within document. You don't want to nest to 7 or 8 levels. Or maybe instead of embedding the documents, right? How much you want to limit the number of embedding. I'm not going to embed more than 100 documents. I'm not going to embed more than 50 documents. Whether it's feasible to do so, yes, no. Again, is a question that you can ask for yourself. Right? Atomicity. When you're talking about atomicity, remember, Couchbase servers, the atomicity at Couchbase server is at the document level. Of course, we have asset transactions. You're going to use asset transactions only when it's necessary. And there's a beautiful talk about asset transactions here. So please stay tuned. Right? If you absolutely need changes to be atomic, then you'll have to make it as a part of the same document. But if you're putting everything within the same document, the document size becomes bigger. The document size becomes bigger, you have all the issues that we discussed earlier. Right? Complexity of the document. So I'm not going to talk about this nickel query here, but my idea is I don't want you to write an extremely complicated nickel query because your document is complex, right? Keep your documents simple so that your querying is simple, right? And speed of access. So as it relates to data modeling, speed of access is critical, right? So remember, when you're using nickel, keep in mind, querying by the document key is the fastest way of accessing the data in Couchbase, right? Querying using second indexes is usually slower, okay? Of course, you can fine tune using appropriate indexes, everything, but there's nothing faster than getting data by the key, okay? So you can use data duplication to improve the speed of accessing related data and thus trade improved speed for greater complexity and a larger document size. So let's talk about embedding versus referring, right? So look at this conceptual model here, right? So I've identified the entities, different entities, address, customer, pay types, contacts, order, items, product, right? So how do I want to do it? So should I do something like this, where I have an order document, and inside order document I have array of items. I have this choice. So where, look at this, items has quite a bit of attributes here within this, or I have a choice of doing something like this, that is keep my products separate here, right? While I refer within this items, I don't keep all the item details within that, rather I just refer that. The choice is yours based on the various trade-offs that we talk about, right? But there are certain guidelines, right? So if the relationship is one-to-one or one-to-many, you want to nest the data, right? If the relationship is many-to-one or many-to-many, you want to refer the data, refer related data. In case you are only reading your parent fields, only the parent fields, then why do you want to nest it and get everything together, right? You want to refer it so that you only read the parent when it is required. That's your requirement, isn't it? But what if you're reading parents and child mostly together always? Nesting is better, isn't it? Because you want both the data together, right? So writes are mostly either to parent or child. In that case, refer. Writes are mostly for both parent and child. In that case, you want to nest it, right? So, and that brings to the end of this session. I hope you enjoyed the session.